Good morning, everyone. My topic is all about magnetic declination. Except in few places, the magnetic meridian at a place does not coincide with the true meridian at that place. The horizontal angle which the magnetic meridian makes the true meridian is known as the magnetic declination, or simply declination of the needle at that place. When the needle is deflected towards east of the true meridian, it is said east declination, and west declination when it is deflected towards west of the true meridian. Since the magnetic meridian varies from place to place and from time to time on the Earth's surface, the amount and direction of the declination is different at different places and at different times. If the true bearing of a line is determined by the astronomical method, the declination of that place can be found by observing the magnetic bearing of that line and finding their difference. The declination can also be obtained approximately from isogonic charts published from time to time to the government agencies. The lines joining the places of equal declination at the same time are called isogonic lines, and the charts showing these lines are called isogonic charts. The lines joining the places of zero declination are known as agonic lines. Variation of magnetic declination. The declination of any place is not constant, but it is subjected to fluctuations or variations which may be regular or irregular. Regular or periodic variations. This class of variation may itself be analyzed into several components of different periods and amplitudes. They are secular, annual, and journal or daily. Secular variation. The magnetic meridian swings like a pendulum. It swings in one direction for a long time, 100 to 200 years, and gradually comes to rest and then swings in the opposite direction. Annual variation is the change produced annually by secular variation, amounts in different places from 0 to positive negative 12 minutes but does not remain constant at any place. Journal variation. It is an oscillation of the needle from its mean position during the day. The amount of this variation varies from 1 minute to about 12 minutes at different places. This is greater in high latitudes than near the equator, and more in summer than in the winter at the same place. Irregular variations. These are caused by magnetic storms such as earthquakes or volcanic eruptions, and their amount may be even 1 degree or 2 degrees at a time. Calculations of true bearing. All survey maps which are to form a permanent record such as revenue survey maps are plotted with reference to the true meridian. And if the survey is made with a compass, the observed magnetic bearings shall have to be converted to the true bearing. The magnetic bearings can be converted to the true bearings by the following rule. Rule 1. True bearing of a line is equal to the magnetic bearing of the line, positive negative declination. Use positive sign when the declination is east, as in figure shown, and negative sign when it is west, as in figure also shown. On the other hand, the magnetic bearing of a line can be deduced from its bearing by the following rule. Rule 2. The magnetic bearing of a line is equal to true bearing of the line, positive negative declination. Use negative sign when the declination is east and positive sign when it is west. Note that the above rules apply only in WCV. Examples or sample problems. The magnetic bearing of a line is 197 degrees. Find the true bearing of the magnetic declination in 3° west. Let's use rule 1, which is true bearing of a line is equal to magnetic bearing of the line minus declination is equals to 197 degrees minus 3 degrees is equals to 194 degrees. Sample number 2. If the magnetic bearing of a line is north 37° west and the magnetic declination is 2° east, find the true bearing. True bearing of a line is equal to magnetic bearing of a line plus negative declination. Magnetic declination is equal to 2° east, and the true bearing will be north 37 degrees minus 2 degrees west is equals to north 35 degrees west. True bearing of a line is 217 degrees and magnetic declination is 2° west. Find the magnetic bearing. Magnetic bearing of a line is equal to true bearing of the line plus declination. So it means 217 degrees plus 2 degrees is equals to 219 degrees. That's all. Thank you.